Okay, today we shall be developing. Today we shall be sorry. We shall be developing unrestricted VAR model. Restricted VAR model. That is our plan. We shall be developing unrestricted VAR model. Okay, so VAR model actually two type. One is restricted, and the second one is unrestricted. So one is restricted and the second one is unrestricted. Okay. Okay, what is the guideline? If the variables are not co-integrated after Johansen test of co-integration, then we can develop unrestricted VAR model. But if the variables are co-integrated, then we must develop restricted VAR model, and that is vector error correction model, right? That meaning that is VECM model. So that is the guideline all the time. And here we have three variables. You can see from here, that is consumption, GDP, and import. Okay, what I do, I make it zoom. You can see all the three variables. So you can see consumption, GDP, and import. That is IMP. Then gross domestic product, then consumption. So we have these three variables, and the sample size from 1970 until 1980, 11 years data that we have. Okay, and what I do, I open all the variables as a group. I'm opening all the variables as a group. So here you can see all the variables, all the data. First is import, then is consumption, and third is GDP. Okay, and here we assume that all the variables are not co-integrated after Johansen test of co-integration. So as the variables are not co-integrated, we can easily run unrestricted VAR model, and that we shall be doing now, unrestricted VAR model, because the variables are not co-integrated after Johansen test of co-integration. And we also assume that all the variables are stationary. All the variables are stationary. That means there is no unit root in the variables. That also we assume. But if the variables are not stationary, suppose if the variables are not stationary, then we have to make it stationary first. Only then we can run the unrestricted VAR models. That means the variable should be stationary. If not, we have to make it stationary. afterwards we can run the unrestricted VAR model, and that we shall be doing now. Okay, I go to quick, I choose the estimate VAR, and here are two things, unrestricted VAR and the vector error correction model. So I choose this one, the first one, unrestricted VAR, because the variables are not co-integrated. Okay, then here endogenous variables. So here I'm putting all the endogenous variables. We have three variables, GDP, then consumption and import, that is IMP. So we have these three variables, right? We have these three variables. So meaning that here after estimating there will be three model, and GDP would be dependent variable, consumption will be also dependent variable, and import, that is IMP, will be also a dependent variable. That means three model will be developed after running this unrestricted VAR model. And here suppose I choose here lag 2, lag 2. Suppose after doing the lag selection criteria advise me to choose 2 lag. So I follow that advice. And I take 2 lags. Okay, so meaning that 2 lag is the most optimum for this model. So I take 2 lags, right? Okay. And the data is from 1970 until 1980. It is already here. Okay, now we can run the models, right? We can run the models. It is the estimation, you can see, right? You can see from here, estimations. Okay, estimation is here, you can see from here, right? Okay. Estimation is here. So here is the vector auto regression model, and here GDP is the dependent variable, consumption is a dependent variable, IMP also a dependent variable. So there are three model. One is GDP, and second model is consumption, third model is import. Okay, so suppose I talk about first GDP. You can see from here it is the dependent variable, and all these things, suppose GDP lag 1, GDP lag 2. Why? Because here I have chosen 2 lag. That means every independent variable, will have 2 lag, and that is here lag 1, GDP lag 1, GDP lag 2. Okay, in the similar way I go down, that is also the second variable is what? Consumption, lag 1 and lag 2. Consumption, lag 1 and lag 2. Then the third endogenous variable, you can see import lag 1, import lag 2, and finally the constant, right? Constant. So that is our model, the first model, where GDP is the dependent variables. And you can see the same thing happen for consumption and also for import. Same thing is happening. Same thing is happening. Okay, here you can see, suppose I talk about GDP. In this GDP, there are how many independent variables are here? How many? 1, 2, 3, 4, 5, 6, and 7, right? So there should be 7 coefficients in total for each regression model. There should be 7. Okay. Okay, suppose I take this variable GDP lag 1, right? And what about this one? 23.8. 23.18 is the coefficient of GDP lag 1. And what about this one? 41.37. That is the standard error of this coefficient. 41.37. What about this one? The third bracket, 0.56043. That is the T statistics, right? So here you can see this one. Standard error means second bracket and T statistics means third bracket. That you can see from here, right? Okay. Now the question is that how to get this T value, that is 0.56043. Okay, what is the formula? The formula of getting T value is coefficient, that is 23.8, divided by standard error, that is 41.37. You can get the T value, that is 0.56043, and it will always happen. Okay, suppose example this one. What about this one? That is under our second model where consumption is the dependent variable. So here the coefficient is how much? 0.171. And what about the standard error? 0.166. And if you divide the coefficient, that is 0.171 with 0.166, that is standard error, you can get the T statistics, that is 1.02839. So that will always happen for all the variables here, right? Suppose this divided by this, you can get this T value, or this divided by this, you can get the T value. So it is for all. The same formula applies for all. Okay, then okay, suppose there are 3 models. One is GDP, one is consumption, and one is import. All you can see below. Below you can see all. Just go down. Go down. It is not here, I'm sorry. So okay, here what is happening? Okay, the thing is that here is my one question that, okay, here I check first one thing. One model has how many coefficient? 1, 2, 3, 4, 5, 6, 7. So every model has 7 coefficient, meaning that we have three model. We have three model, that is GDP, consumption, and IMP, import. So in total, in the whole system, there should be 21 coefficient. That means 3 multiplied by 7, right? Each model has 7 coefficient, meaning that we should have 27 coefficient in the whole system. We call it VAR system, unrestricted VAR system. Okay, from this unrestricted VAR system, what is happening here, you can see. Okay, first suppose I have one question, whether consumption 1 is a significant variable or not to explain GDP. Whether consumption lag 1, is it significant to explain GDP? Yes, from the t value, we can know the answer, right? But if I know the p value, p, not t, if I know the p value, then I can answer better, easier if we have p value. But here is no p value. Here is all t value. Okay, what about the second question? Suppose GDP lag 2, that is this one, GDP lag 2, whether this variable is significant to explain import, IMP. How to know? Okay, the answer is from t value. From here, probably we can give the answer. But if we have p value, probability value, we can answer better. So what is the guideline? The guideline is, if the p value is less than 5%, then that particular variable is significant. Or if the p value is more than 5%, then that particular variable is not significant. So that is the normal guideline all the time. So here we got to know the p value. Then we can easily answer very fast. Our life will be easier to explain the answer if we have p value. Okay, so now the question is that how to get the p value? How to get the p value or probability value, right? How to get it? Okay, in this system equation. Okay, we can get the p value easily from here. Okay, how to get it? Okay, what I do, okay, how to get the p value? Okay, I go to proc, then I go to make system, because it is system model. So I take make system, then order by variable. I choose this one. Okay, you can see our system model. Okay, we have three model. One is GDP, and the second one is consumption, and third one is import. Okay, so here you can see C1 actually the coefficient of GDP lag 1, and C2 is the coefficient of GDP lag 2, talk about C3 is the coefficient of consumption lag 1. C4 is the coefficient of consumption lag 2. C5 is the coefficient of import lag 1. And C6 is the coefficient of import lag 2. And finally intercept, constant of the first model, that is under GDP. Okay, then the second one, okay, the first one has been ended at C7, so second one will begin from C8 because it is system equation model, they are linked with each other. C7, so it start with C8. What is C8? C8 is the coefficient of GDP lag 1. Then C9 is the coefficient of GDP lag 2. And the whole thing actually ended here, ended at C14. So meaning that the next one should begin from C15. In this way, the last one is C21. So meaning that it has started from C1 and ended at C21. So it can estimate 21 coefficient. It can estimate 21 coefficient plus 21 p-values. So here I am telling again what is happening. Here she can estimate 21 coefficient, so meaning that she can also estimate 21 p-values, and that we shall be doing now. Okay, how to estimate all the coefficient? How to estimate all the coefficient? That is the question now. To estimate all the coefficient, I go to estimate, right? Here is a icon, you can see. I click on it, and here they are talking about estimation method, and that is ordinary least square, meaning that OLS, right? And we can use it. We can use the OLS method to estimate the system equation. Okay, then I press OK. I press OK. So the result has come up. You can see the result, right? The result has come up. The result of the system equation. I'll just make it big. I'm sorry. I make it slightly big. Okay. The result of system equation has come up. You can see from here, right? So meaning that you can see here that just make it. I make it slightly big. Just 1 minute. Just 1 minute. I make it slightly big. Okay. So it is the result of the system equation. You can see system equation, right? So here are the 21 coefficient. You see from here C1, C2, C3, C4 until C21. So there are 21 coefficient has been estimated at a time. 21 coefficient has been estimated at a time. So the whole thing actually called system equations. Okay, and in this, just 1 minute, just double check one thing. just one check. Okay. Just 1 minute. Okay. And you can see from here, in this system equation, you can see suppose I talk about the first one, C1. What is C1? The coefficient. So it is the coefficient 23.8 divided by the standard error 41.37. So coefficient divided by standard error, you can get the t statistics. So that is the formula. Coefficient divided by standard error, you can get the t statistics, and 0.5955 is actually the p value, the probability value that we are looking for, right? Probability value. So in this way, you can see all the probability value for 21 coefficient. Suppose the last one, C21, the probability is how much? 0.9099, meaning that 90.99%, meaning that this particular coefficient, that is C21, is not significant because the p-value is very high. What about the first one, C1? Is it significant? So how much is the p-value? 59.55, which is more than 5%. So it is not also significant variable here. Okay, in this way, we can check all the variables, whether they are significant or not. Okay, now we can see some more things. At the below, you can see we have three models. The first model is this one, and here the GDP is the dependent variable, and these are all independent variable until C7, right? So that is the first model. And the second model equation, second model actually start with consumption. So consumption, it is C7, it start with C8, right? C8, C9, C10, C11, 12, then C14. That is the constant of this model. And what about the last model? That is import, IMP. What is IMP? Import. That is the dependent variable. And all these things are independent variable. So the last one is C21. What is C21? C21 actually the constant of IMP model. C21 actually the constant of IMP, meaning that import variable. Okay, suppose I check whether import lag 1, this variable import lag 1, is this variable is significant to explain our dependent variable, and that is consumption. That we want to check. Okay, I'm telling again whether import lag 1, is this variable is significant to explain our consumption. Okay, so how much is C12? What is import lag 1? Import lag 1 means C12, right? C12. So we go up to check C12 and we check the p-value of C12. P-value is how much? 49.37%, which is more than 5%. So it is not a significant variable. Okay, in this way, suppose we can take this one. Suppose I take, suppose C3, suppose consumption lag 1. Consumption lag 1. Is it significant to explain our GDP? Okay. Consumption lag 1 means what? C3. Consumption lag 1 means C3. Is it significant to explain GDP? Right? Okay, I go to C3. That is C3. And what is the p-value of this C3? P-value is 48.79%. P-value is 48.79%, and which is more than 5%. So C3 is not a significant variable, meaning that I can say it is here C3 is not significant, meaning that consumption lag 1 variable cannot influence the dependent variable, and that is GDP. So in this way we can check all the variables individually, whether they are significant or not. Individually we can check whether they are significant or not. Okay. So here I'm talking about individual significance. What about joint significance? Joint significance. One is individual, right? And the second one is joint significance, right? Joint significance, right? Okay, what does mean by joint significance here? Suppose I want to check whether IMP lag 1 and IMP lag 2, these two variables jointly can cause the GDP or not. Whether import lag 1, import lag 2 jointly can influence GDP or not. That we want to check. That means whether import lag 1 and import lag 2 can cause GDP or not. That we want to check. Okay, to check it, we shall have to use Wald test, right? Wald test, and that is called actually joint significance test, right? So we call it Wald test or joint significance test, or we can also call it Wald coefficient test, right? That is also another thing. So we can say about it. Okay, so we set our null hypothesis here. So here is our null hypothesis, whether C5 and C6 equal to 0 or not. That we want to check. I'm doing again. The null hypothesis is for this model, just I'm writing here, whether C5 equal to C6 equal to 0 or not. So that is the null hypothesis. I'm doing here. C5 and C6 is equal to 0 or not. That is our null hypothesis. And if the C5 and C6, if it is 0, meaning that import lag 1 and import lag 2 cannot jointly influence our dependent variable, which is GDP. But if C5 and C6 are not jointly 0, that means if we can reject null hypothesis, meaning that import lag 1, import lag 2 jointly can influence GDP. Okay, that we do now. Okay, so we do the Wald coefficient test. So how to do it? Okay, I go to view, then I go to coefficient diagnostic, right? Then Wald coefficient test. So I put this two coefficient C5, C5 equal to C6, right? Equal to 0. That is my null hypothesis, right? That is the null hypothesis that we have set here. That is the null hypothesis. So I press OK. So this is the outcome of our result. It is the Wald test, right? You can see. And it is the null hypothesis C5, C6, 0. And it is the test statistics chi-square, and it is the p-value. How much is the p-value? 55.47%. 55.47%, which is more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that C5, C6 is equal to 0. We accept it, meaning that C5, C6 equal to 0 means, just 1 minute, I have lost the whole things. Okay, it means that, sorry, not here, I put it where C5, C6, 0, meaning this, just 1 minute. Why? Okay, just 1 minute. Okay, just 1 minute. I do this. Just 1 minute. Just 1 minute. Okay. Yes, I compare. C5, C6 is 0, meaning that import lag 1, import lag 2 jointly cannot cause the GDP, or import lag 1, import lag 2 jointly cannot influence our GDP variable, which is dependent variable. Okay, in the same way, we can take, suppose, another example. Suppose talk about this one, import, that is the dependent variable. Suppose here we want to check whether GDP lag 1 and GDP lag 2 whether this variable, two variables jointly can influence import or not, right? That we want to check. So here we have two coefficient C15 and C16, right? So we set the hypothesis as before. What is our hypothesis now? The hypothesis is here C15 equal to C16. Are they 0 or not? That is our null hypothesis. C15, C16. Okay. That is 0 or not. We set the hypothesis. So as before, I go to view and coefficient diagnostic, then Wald coefficient test, right? So here I set the hypothesis C15 equal to C16 equal to 0, right? Equal to 0. So that is my null hypothesis. I press OK. So here what is happening? C15 and C16 0, that is the null hypothesis, and it is the Wald test, it is the test statistics. What is the p-value? 62.38%, which is more than 5%. So we cannot reject null hypothesis, meaning that GDP lag 1 and GDP lag 2 jointly cannot influence the dependent variable, which is import, or GDP lag 1 or GDP lag 2 jointly cannot cause the dependent variable, which is import. So in this way we can check all the joint significancy test by using Wald coefficient test.